Hello friends, and in this lecture we are going to discuss about the partial differentiation. So consider here u is the function of f, x and y. So this x and y are two variables here. So when you are differentiating this u with respect to x, differentiate u with respect to x keeping y as a constant is called as del u by del x, and that is partial differentiation of u with respect to x. This is also represented as a u of x. So when you are differentiating with respect to x, we need to keep y as a constant. Yeah, treat y as a constant. Only differentiate the x terms. That is ux. Yeah, del u by del x. Similarly, when you are differentiating with respect to y, del u by del y, this is partial differentiation of u with respect to y, treating x as a constant. And here y as a constant. So del u by del x, this is del u by del y. This is also called as limit when it's changing from del of x is tends to 0 and f of x plus del x comma y minus f of xy divided by del x, which means here x is changing x plus delta x to x. So rate of change of x is changing here, that's why that is del u by del x. Yeah, u of x called. Similarly, when you are differentiating with respect to del u by del y, means is changing the value of y. Limit of del of y tends to 0, and here the values of x is constant. Y it's become y plus del y minus f of x to y divided by del y. So this is meant by u of y. So mainly, if we were given the function u is equal to f of xy with the two variables, you can differentiate partially with respect to x, treating y as a constant, that is del u by del x, also called as u of x. Similarly, we do partial differentiation with respect to y, that is del u by del y, and also called as u of y. Now again, this is the first order derivatives. Now again, if you differentiate this del u by del x with respect to x, so you are differentiating with respect to x for the input del u by del x. So this is called as del square of u by del x square. This is for the treating x as a differentiating with respect to x, keeping y as a constant. Whatever the y terms is there, we need to keep as a constant, and differentiating with respect to it twice. That's why it's called as u, x, and x. Similarly, if we differentiate with respect to y, so this del y, if we are differentiating with the input of del u by del x, so it becomes del square of u by del y del x. Similarly, for the u of y, if we differentiating with respect to x, so differentiation with respect to x for the input del u by del y, this is del square of u by del of x and y. That is meant by u of x and y. This is u of y and x. And again, if you differentiate respect to y, so input is del u by del y, which becomes del square of u by del y square, and this is u of y. So this is second order here. Second order mixed partial derivative is called as these two values, and this will be always same. This u of xy is equal to u of yx. So sometimes questions also will come if any function is given and we need to prove partial differentiation of this mixed type second order partial derivatives. So we'll see the example here. So we'll see the class 2 questions. So this are the question is given here, and we need to find here del square of z, this u with respect to x square, and del square of u by del y square. So these are the question is given in the assignment, and now let's start for the first one. So z is equal to given here e to the power of x by y. We need to differentiate here partially with respect to x. So we can write del z by del x is equal to e to the power of x differentiations. So what is the e to the power x differentiation? As it is only e to the power of x by y. Now this x by y we need to differentiate with respect to x. So here the constant is 1 by y, and remaining will be left here x, and x differentiation is 1. So we can write here this one times of 1 by y. Similarly, if we want to find differentiation with respect to y, we can write here e to the power of x by y is as it is. Now this x by y we need to differentiate with respect to y. So x is constant here. So now remaining is 1 by y, and 1 by y differentiation is minus 1 by y square. Okay, right? Because y to the power of minus 1, and you can write it here minus 1 y to the power of minus 1 minus 1. So it will become minus 1 by y square. So this becomes minus 1 by y square. So this is the differentiation with respect to x and y for the first one. Now for the second one is given here z is equal to e to the power of x. Second given here z is equal to x cos of xy plus y sin of xy. So here differentiation with respect to x. So differentiate here x keeping y as a constant. So we can see here in the x, in this here also is there, and this in the angle of the cos also is there. So two function is there just like. So we need to apply u into v. So u into v differentiation, u v dash plus v u dash. X as it is only, cos differentiation is minus of sin of xy. Now in the bracket here this angle xy, and xy we have to differentiate this xy, we need to differentiate with respect to x. So y is the constant outside, and x differentiation is 1. So we can write only y. So in this xy we are differentiating partially with respect to x. So y is the constant, x differentiation is 1. So we'll get it here 1. So u into dv by dx is over plus v cos of xy into this x differentiation is 1 plus this terms. We are differentiating with this partially with respect to x. So y is constant here, y you can take outside constant, and sin differentiation is cos of xy, and again xy differentiation with respect to x becomes only y. Similarly, if we are differentiating partially with respect to y, so here x is the constant, cos differentiation is minus sin of xy. Now xy we are differentiating with respect to y. So here x is the constant, y differentiation is 1. So we can write here into x plus here two function is there. This is y, and this is with the sign also angle is there. So you need to apply again u into v here. So y cos of xy, and xy with respect to y is x plus sin of xy, and this y differentiation is 1. So this is del z by del y. Now if you want, you can simplify, you can take the common things. Next, third one is z is equal to log of x square plus y square. So differentiation with respect to x, this log differentiation is 1 upon x square plus y square. Now this bracket part x square plus y square we have to differentiate with respect to x. So x square differentiation is 2x, and y square is complete constant here, and y square differentiation is 0. So we can write only this 2x. Similarly, with respect to y, we'll get it 1 upon x square plus y square, and x square plus y square, this bracket part we need to differentiate it with respect to y. So x is constant here 0 and y square is 2y. So this is partial differentiation of z with respect to y. Next question is going to need to verify here z is equal to cos inverse of xy, and you have to prove it del square of u del x del y is equal to del square of u del y del x. So we are starting from the LHS, this left hand side. So if you break this one, we can write del by del of x or del u by del y. So this u or z, whatever given here, we need to first differentiate with respect to y, and that result with respect to x for the LHS. So first we find the del u by del y. So cos inverse differentiation is minus of 1 by a square root of 1 minus angle square. So angle is here xy, that one L whole square. Now this xy we need to differentiate with respect to y. So x is constant and y differentiation is 1. So we will get it here minus x divided by a square root of 1 minus xy whole square. Now this result we have to differentiate with respect to x. So this del u by del y we are differentiating with respect to x here. So this becomes del square of u del x del y. So if you are differentiating with respect to x, this one here, so here in the numerator also x and the denominator also x is there. So we need to apply the division u by v formula, which is v into u dash minus u into v dash divided by v square. V is this part. This is square root of 1 minus x y whole square into u dash, this x with respect to x. So 1 minus, let's take outside for the whole, minus u. U is x as it is. This is square root of this one differentiation. So we can write here the square root of x differentiation is 1 upon 2 root of a square root of 1 minus x and y whole square. Now this bracket have to differentiate with respect to x. So one differentiation is 0 minus, this is x square y square, and we are differentiating with respect to x. So y square is a constant and x square differentiation is 2x. This one divided by, we can write it here, a square root of 1 minus x y whole square. This is total whole square. So if you want to simplify, you can simplify here. We can take common here. This 2 and this 2 is cancelled here. So this square root and this square root will get cancelled. If you take the LCM here, we will get it here 1 minus xy, that one whole square, minus, this minus minus become plus, this 2 x square y square divided by, this is 1 and this is root. So 1 plus half is 3 by 2. So we get it 1 minus this xy to the power of 3 by 2. So this is the LHS side. Similarly, we will prove here this part also. So for proving this part, we need to first differentiate with respect to x and then y. So z is equal to cos inverse of this x, y. First differentiate with respect to x, because we are doing this one with respect to y. So del z by del x is equal to minus of 1 upon a square root of 1 minus this xy whole square. Now this xy this xy we need to differentiate with respect to x. Sorry, first we are doing with respect to x. So if we're differentiating with respect to x here, xy, so y is the constant here and x differentiation becomes 1. Now this del z by del x we need to differentiate with respect to y. So in the numerator and denominator both y is there, so again here you have to apply u by v. So minus I taken outside here, a square root of 1 minus this xy whole square, and y differentiation is 1 minus y as it is only. This one differentiation is 1 upon 2 root of a square root of 1 minus this xy whole square, and this one differentiation 1 is 0 minus x square y square differentiation with respect to y. So x square as it is only, and y square differentiation is 2y. This one divided by a square root of 1 minus this xy whole square, this total whole square. So simplify this one here, minus this one LCM here. If you take here, these two and these two get cancelled here. This will get it 1 minus this xy whole square. This minus minus become plus. This become 2 x square y square, and 2 to get cancelled here, so only x square y square, and this square root cancelled, so it will come down here. So 1 minus this xy whole square to the power of 3 by 2. So this values, and if you see for the partial differentiation of this one is same one. There are no t here. This 2 is get cancelled here, so this much out. So both are the same here. So we can say that here this mixed type partial differentiations, this both are same. Means del square of u by del x del y is equal to del square of u del y del x. So next questions. This one also same. We need to prove this one mixed type. So first for the LHS, if you are doing u of x y, means del square of u del x del y. So if you break it del by del of x, and this del u by del y is the input for the del by del x. So first we need to differentiate with respect to y. So this is u या z anything. So we differentiate this u with respect to y. So e to the power of anything differentiation is e to the power as it is only, this x cos y plus y cos of x. Now this part we need to differentiate with respect to y. So x is constant here, cos y differentiation is minus sin y, plus this one with respect to y. So cos of x is the constant and y differentiation is 1. This. Now this result we need to differentiate with respect to x. So this term also x having, and this also having the x. So we need to apply u into v. So u differentiation, u as it is only e power of x cos of y plus y cos of x. This one differentiation with respect to x. So sin y is a constant, x differentiation is 1 and minus as it is, plus cos x differentiation is minus sin x. This one. Next, plus this one we can write as it is only, this cos of x minus x sin of y. Now this one differentiation. So e to the power of x cos y plus y cos of x as it is into this exponent power of this one with respect to y, with respect to x. So here x differentiation is 1, this become cos of y, and this one y as it is, and cosine differentiation is minus sin of x. This one will do it. So this is the LHS set. No need to simplify, you can check out. If you want, you can simplify here. This one you can take, if anything is common here, you can cancel it. You can write here this one as it is into sine of y. Okay, yeah, leave it as it is only. Let's see, check for the right hand side, and then we'll compare and we'll cancel it if something required. So RHS, if we're doing here, we are doing here del of y with respect to del u by del x. So first we have to differentiate with respect to x. So z is equal to e to the power of that x cos y plus y cos of x is given. So if we differentiate this one with respect to x, e to the power of x cos of y plus y cos of x as it is. Now in the bracket this part differentiation with respect to x. So x differentiation is 1, cos of y is as it is, and this one y is constant, and cos y differentiation is minus sin of y. Now this one we have to differentiate with respect to y. So y in this term also is there, and this term also there. So u into v. So this is u, and this one differentiation with respect to y. Cos differentiation is minus sin of y, and this one differentiation with respect to y, we need to apply u into v. Here. 1 minute. This is with respect to cos of x. This is x here. This cos will become sin of x. This is x. So y differentiation is 1 here. This is minus sin of x plus this cos of y minus y sin of x as it is. This one differentiation with respect to y. So e to the power of x cos of y plus y cos of x, and this one differentiation with respect to y. So x as it is only, and cos differentiation is minus sin y, and this is with respect to y is 1, and cos of x. So this and this one you can check out, it's same or not. This part is same. This is minus sin y minus sin x, correct? Same. Here cos of x, and this is cos of y minus y sin of x, correct? And this is as it is, and this is cos of x minus x sin y. So both are same here. So we can say that u of xy is equal to u of yx. So we'll go for the next questions. From this one, from the LHS, u of this x and y. So del u by del x, and this del u by del y. So first we need to differentiate with respect to y, and that result with respect to x. So let's differentiate with respect to y first. So here you can see here y is the numerator also, denominator also. So this is just like a two functions u by v. So v as it is only, and xy differentiation with respect to y. So x is as it is, and y differentiation is 1, minus this xy as it is, this one differentiation, this differentiation with respect to y. So y is 1 and x is 0. So we can write only this one, divided by x, this y minus x whole square. So if we simplify here, this is xy minus x square and minus xy. divided by this y minus x whole square. This part cancel here. So minus x square divided by y minus x whole square. Now this one if we differentiate with respect to this y with differentiate with respect to x. So here also we have to apply u into u by v. So minus you take outside better. U by v means v as it is only. This one differentiation with respect to x, which is gives 2x minus this x square as it is. This one differentiation with respect to x. So it's give 2 into y minus x into y differentiation is 0, x is minus 1 divided by this y minus x this whole square. So we can write here this is minus as it is. If you want, you can take the common here y minus x and you can cancel this. So y minus x will be remaining here into 2x and this one minus becomes plus here and this is 2, this x square, 2x square divided by y minus x whole square. So whole square one part is already cancelled here, so only y minus x. So if you simplify further, you can write 2xy minus 2x square plus 2x square divided by y minus x. So this part is cancelled here, 2xy divided by y minus x. So now we'll see for the right hand side. So that u is equal to xy by y minus x. So now you need to find the del square of u, this del x, del y, right? This one we did, y of x you have to do it. So del y, del x. So first we need to differentiate with respect to x. So u with respect to x. So here u by v. So u by v means y minus x as it is. Xy differentiation with respect to x. So only y will be left minus xy. This one differentiation with respect to x. So y is 0 and x is minus 1. So become this one plus 1. And this is x, y minus x as it is. Y minus x whole square. So this becomes y square minus xy plus xy divided by y minus x whole square. This is cancelled here, so y square divided by y minus x whole square. So now this del u by del x we have to differentiate with respect to y. So del square of u by del y del x. So u by v have to apply. So y minus x whole square and y square differentiation is 2y minus y square as it is. This one differentiation is 2 times of y minus x into y differentiation is 1 and x is 0 divided by y minus x whole square. And this whole to the power of 4 will come. Here also this becomes 4x, sorry. This becomes 4, so 1 if you cancel here, it becomes 3 here. So now here y minus x if you take the common here. So here we will left y minus x and 2y minus here 2y square divided by y minus x to the power of 3 because y minus x is common and cancel. So now further if you simplify here, this is 2y square and minus 2xy minus 2y square divided by that is y minus x whole cube. This part and this part is cancelled here. So getting here this minus of 2xy divided by y minus x whole cube. So check with the RSS. This one is getting positive here. No, this is also minus here because this is outside minus over there. This part. So this one 2xy minus 2xy minus 2 of xy and y divided by y minus x2 both are same. So we can say that u of xy is equal to u of yx. This u is given here. We need to find double differentiation with respect to x two times. So first we find del u by del x. So this becomes 3x square. Here 3y square is constant and x differentiation is 1. So we will write 3y square. Here x differentiation is 1 plus here e power x cos y. Cos y is a constant and e power of x differentiation is e power of x and 1 differentiation is 0. Similarly, we can differentiate one more times with respect to x. So this becomes 6x. This is 3y square is complete constant. There is no x here. So it becomes 0 here. This is also 0. And this one is cos of y is constant here. And e power of x differentiation is e power of x. This is the del square of u by del x square. Similarly, we can find for del u by del y. First, this is 0. This becomes minus 6 xy. This is 0. E power x differentiation is e power of x and cos of y becomes minus sin of y. And this one differentiation is 0. Now again if we are differentiating with respect to y, this becomes minus 6 of x and this one minus with respect to y. So e power of x is constant and sin y differentiation is cos of y. So this is with respect to y twice. Friends, the lecture number 3, that problem based on class 3, and question is given here u is equal to this one and we need to prove here del u by del x plus del u by del y plus del u by del h del z is equal to 0. So del u by del x means when you are differentiating with respect to x, keep y and z is a constant. So here in these terms there is no any x. This one and this one x term is there. So this one I can take outside and here we can apply the product rule. So y minus z I will take common here outside and this one u into the product rule. So z minus x as it is. This x minus y differentiation with respect to x. The x differentiation is 1 and y is 0. Plus this x minus y as it is. This z minus x differentiation with respect to x. So z differentiation is 0 and x differentiation is minus 1. So we'll get it this one. So if we simplify here, we can write y minus z and this one we take the z minus x minus here if we multiply, so we will get it minus x and plus 1. So we can write it here y minus z and this one z minus 2x plus 1. So if we multiply this one here, this whole terms, we can write here this is yz minus 2xy and y times this one is y square minus z square plus 2zx and minus zy. So anything cancel here? This zy and zy is cancelled. So we'll get it here, this u of x, del u by del x is equal to that y square minus z square minus 2xy plus 2xz. Similarly for the another no need to show, we can write for the del u by del y also. We can find the conclusion here. When x is there, these two terms are apart from x, means y and z. And here we are getting this x with conjugative y and this plus with x and z. So similarly del u by del y I can write it. Here y should not come. So means z square minus x square minus 2yz plus 2xy. If you want, you can check out by doing this. So del u by del z, similarly we can write it here, this x square minus y square minus 2zx plus 2zy. So if you add it all three, this del u by del x plus del u by del y plus del u by del z. So you can check out here what will be cancelled here. This z square cancel x square cancel, y square cancel. This 2xy is plus 2xy minus 2zx. This one cancel, this one cancel. Everything is cancelled here, so it becomes 0. So next questions. So these questions, first we'll differentiate with respect to x here. We have to show that this one. So del u by del x is equal to, we can write it here, u is equal to log of tan of x plus tan y plus tan of z is given. So we know that log differentiation is 1 by this bracket whatever given here, which is tan of x plus tan of y plus tan of z. Now this bracket part we need to differentiate with respect to x. So tan of x differentiation is with respect to x, secant square of x, and tan y and tan z is 0 because differentiation with respect to x, another variable is constant and 0. So we can write it here, this secant square as it is on. Now in this del u by del x we have to multiply this sine 2x. So we will multiply here sine of 2x into del u by del x. So we will get it here sine 2x into secant square of x divided by tan of x plus tan of y plus tan of z. This one also we can write sine 2x, we can write 2 sine of x into cos of x, this compound angle, and secant square is 1 by cos x square. This tan of x plus tan of y plus tan of z as it is. This one with respect to 1 by, this is cos square of x. So 1 cos will get cancelled here. So 2 and sine by cos becomes tan. So you can write 2 tan of x divided by tan of x plus tan of y plus tan of z. So this is sine 2x times del u by del x. Similarly we can write for the sine 2y into del u by del y is equal to, what we can write, 2 tan x comes here, we can write 2 tan of y divided by tan of x plus tan of y plus tan of z. Similarly for the sine 2z del u by del z become 2 tan of z divided by this tan of x plus tan of y plus tan of z. So now if you add it, this one, all three, this 1, 2 and 3. So left hand side will get it, this one, same thing. So we'll get it here sine of 2x into del u by del x plus sine 2y into del u by del y plus sine 2z into del u by del z is equal to, we can here, if you add it, this one, we can take the common this one, that denominator part, 1 upon tan of x plus tan of y plus tan of z is common here. So in the numerator we will get it 2 tan of x plus 2 tan of, here also we can take 2 in the next step, tan y plus this 2 tan of z. So we can write here 2 common here, this tan of x plus tan of y plus tan of z, and this one tan of x will be same thing out. So this part is get cancelled here, so we'll get it only this 2, that is RHS. So this one is given u is equal to log of rho, and where rho square is equal to this one, and we prove it, del square of u del x square, and this one is equal to 1 by rho square. So since rho square is equal to this one is given, so we can find the root rho values. This rho value is a square root of this x minus a whole square plus y minus b whole square plus z minus c whole square. So now we will substitute the value of rho that row values here. So u is equal to becomes log of that x minus a whole square plus y minus b whole square plus z minus c that whole square is whole to the power of 1 by 2, which also we can write 1 by 2 log of that x minus a whole square plus y minus b whole square plus z minus c this square. So now this u we have to differentiate with respect to x two times. So first let's try del u by del x first. Del u by del x log differentiation is 1 by 2 constant outside. Log differentiation is 1 by everything as it is. So it becomes 1 upon this whole thing is just like a indices of log. So 1 log differentiation is 1 by everything. So you can write 1 x minus a whole square plus y minus b whole square plus z minus c whole square. This one. Now this have to differentiate with respect to x. So this becomes 2 into that x minus a whole, the 2 minus 1 become 1, and inside differentiation x becomes 1 and a is 0. This one. And this is constant here. So 0. So only this much will get it. This 2 and 2 get cancelled. So we'll get it here. That is x minus a divided by this x minus a whole square plus y minus b whole square plus z minus c whole square. Now we need to differentiate once again. So del square of u by del x square. This is two functions here. So we have to apply u by v formula here. So u by v means v. This x minus a whole square plus y minus b whole square plus z minus c whole square. This one differentiation x is 1 and this is 0. So 1 minus this x minus a as it is. This one differentiation becomes 2 into x minus a, and this x is 1, a is 0, another will be 0, because this all with respect to x becomes 0, divided by this x minus a whole square plus y minus b whole square plus z minus c square. This one total whole square. So if you can take anything common here, so this is 2 into x minus a whole square, and this is x minus a whole square. So I can write it this one in the form of this y minus b whole square plus z minus c whole square. This is 1 minus 2. This become minus x minus a whole square divided by denominator as it is. So this is del square of u by del x square. Similarly, we can write for the del square of u del y square. So y square, this will be y minus b whole square, and this x and z will be the positive. So you can write here x minus a whole square plus z minus c whole square minus y minus b whole square, and this one is x minus a whole square plus y minus b as it is. This one. Similarly, del square of u by del z square, we can write it here. So z part will be negative here. So x minus a whole square plus y minus b whole square plus that minus becomes z minus c whole square divided by this x minus a whole square plus y minus b whole square plus z minus c whole square. This one whole square. So now if you see here, we need to add this all three. So if you add it here, del square of u by del x square plus del square of u y square del square of u del z square. So here the denominator is same only, so we can take common here. So we'll get it 1 upon this x minus a plus y minus b plus z minus c. This one whole square is common. So in the numerator what will you get here? Y minus b, z minus c and x minus a. So this x minus a I will mark with a different color. This x minus a will cancel to the this one. This y minus b will cancel to the this one. One part will cancel. And this z minus c similarly will cancel to the this one z minus. So what is left here? X minus a, y minus b and z minus c. So x minus a whole square plus y minus b whole square plus z minus c whole square, that will be remaining. So we can write this one as a this four things we cancel with the one power. So we'll get it 1 upon that x minus a plus y minus b whole square plus z minus c whole square, and this one is rho square only. You can see here this is rho square only, so we'll get it 1 by rho square. So this is RHS only. So next this question is given here, z is equal to this one, and we have to prove this del square of z del s square plus del square of z del s del y minus 6 times of del square of z by del y square is equal to y cos of x. So let's try here. First we will find this one. So differentiate this z with respect to x. So f differentiation becomes f dash of y minus 3x, and inside differentiation is y is 0 and f minus 3x is minus 3 because we are differentiating with respect to minus, we are differentiating with respect to x. So it will become minus 3 plus phi dash of y plus 2x into y is 0 and 2x is 2. This one sin of x become cos of x minus y is constant here, and cos of x differentiation with respect to x is that minus sin of x, so it become plus sin of x. Now this one with respect to x, one second. So this becomes f double dash of y minus 3x and minus 3 into minus 3, so this becomes 9 plus f phi double dash of y plus 2x into 2 again, so 2 becomes 4. Cos differentiation minus sin of x, and here y is a constant here, y and sin of x differentiation is cos of x. So this is the first part of this one. Now you differentiate with respect to y. So this one becomes f dash of y minus 3x, y differentiation is 1 and 3x is 0 because we are differentiating with respect to y. So plus phi dash of y plus 2x times 1 plus 0, so 1 plus sin of x differentiation becomes 0 because there is no any y here, and this one y differentiation becomes 1 and cos x as it is, so it becomes this one minus cos of x. This one you differentiate with respect to now x to get it this one. So if you differentiate with respect to x, we get it f double dash of y minus 3x times minus 3 plus phi double dash y plus 2x times this 2, and this one with respect to differentiation is plus sin of x. Cos x differentiation is minus sin of x, so minus 1 will become plus. Now del square of z by del y square, this one again with respect to y, so we'll get it f double dash of y minus 3x into 1 plus phi double dash of y plus 2x into 1, and cos x is constant 0. So this one is what, second part, and this is third part. Now all three we have to add it, and this one first one direct, second direct, and third one you have to multiply here minus 6. So if you write it here, this del square of z by del x square plus del square of z by del x del y minus 6 times of del square of z by del y square. We'll get it here, this one as it is. So this is 9 f double dash of y minus 3x plus 4 into 5 double dash of y plus 2x minus sine of x plus y cos of x. This one with respect, this one as it is only substitute here, minus 3 f double dash of y minus 3x plus 2 into 5 double dash of y plus 2x plus sine of x. And this one we multiply with 6, so it become minus 6 we have to multiply. So minus 6 times of f double dash of y minus 3x minus 6 5 double dash of y plus 2x. So now if we add it all, this I will add with a different color. This 6 and 3 9 and 9 cancel. 4 plus 2 6 and this one 6 cancel. And this sine and sine is cancel. So we'll get it here, y cos of x, which is RHS. This one. Next question. In this question is given at what rate the area of rectangle is changing if its length is 15 meters. Length is equal to given here 15 meters and increasing with this 3 meter per second. So length is what increasing, this dl by dt. This length with depend upon the time. This dl by dt we can write it here, increasing with 3 meter per second. While width, let's consider b is the width here, is 6 meters, increasing with this one db by dt we can write here that it's changing with 2 meters per second. So we need to find what is the area of rectangle will change here. So we know that area of rectangle A is equal to this L into B. So area, if we differentiate this one here with respect to T, because we need to find here area with respect to T, how much is changing here. So here L and B both are variable here, so we need to apply U into B. So L into this dB by dt plus B into dl by dt. So L is equal to given here 15 into dB by dt, which is 2, plus B as it is, B is that 6 times dl by dt, which is 3. So you can write this is 30 and plus 6 3 is 80. This is 48 meters square per second. This is the area, rate of change of area. Welcome to the class 4, and in this lecture we will discuss about the total derivative, chain rules and composite functions. So first question is given here, u is equal to sine of x by y, where x is equal to e to the power of t and y is equal to t square, and we need to find here total derivative of u with respect to t. So whenever you are applying the chain rules, first keep in mind here, please check out what are the variables is given. U is given in term of, u is given in the function of that x and y, and this x and y is dependent upon the t, this t, and we are finding that total derivatives of u to t here, this one, this is del u by del t. So where the two variable is there, we can write partial differentiations, del u by del x, this is del u by del y. This one dx, x directly depend upon the t, so we can write dx by dt. This y also directly depend upon the t, so dy by dt. So when we are going to u to t, this du by dt, this du by dt you can write it here, either you can go by this way or this way. So we can write here this del u by del x into this dx by dt plus this way del u by del y into dy by dt. So this is the way you can write the formula for the chain rule. So du by dt we want to find here. We find the del u by del x, this u with respect to x. So del u by del x, we'll get it here. Sign differentiation is cos of this x by y. Now x by y with respect to x. So 1 by y is constant and x differentiation is 1. So we can write cos of this x by y into 1 by y times dx by dt. So this is x. So dx by dt is equal to here this e to the power of t. So we can write e power of t plus del u by del y. This u with respect to y. So del u by del y I can write it here. Cos of this x by y. Now x by y with respect to y. So x is constant and 1 by y differentiation is that minus of 1 by y square. So cos of x by y times this minus of x by y square into dy by dt. This is y with respect to t. This becomes 2t. So you write 2 into t. Okay, so now you can put the values of x in this, which is given in the form of composite function, a parametric form. So we can write here du by dt is equal to cos of x value is e power t and y value is t square into this 1 upon t square e to the power of t plus cos of e to the power of t by t square minus x value is e to the power of t and y value is y square. So t square becomes t power of 4 times 2t. So what is the common here? Common terms you can write this 1t and 1t, it cancel here. So this e power of t by t square and cos of this e power t divided by t square you can take common here. So here we left 1 and here this is outside and e power t outside and t square is taken outside. So 2 and t is remaining. So 2 by t. So this is the this is the answer. Next questions. Z is equal to given x y square plus x square y, where x is equal to 80 square and y is equal to 280. We have to find this dz by dt, total derivatives, and we have to verify by the direct substitution. So you can check out here. This is also z is dependent upon the x and y, and this x and y totally depend upon the t. So we need to find here this dz by dt. So whenever the two variable is given, so partial differentiation, and this one direct is there. So this is x by dt and dy by dt. So z to t directly we want to go here. We can go either by this way or this way. So we can write del z by del x into dx by dt plus del z by del y into dy by dt. So del z by del x here, this one with respect to x. So we can write y square is constant here, x is 1 and this one is 2xy. Dx by dt, this one with respect to t. So it will become 280 plus del z by del y. So this one becomes x is constant 2xy plus x square and dy by dt, which becomes 2. So if you want to put it here all the values in term of t, so we can write here this y value is 280. So y square becomes 4a square t square plus 2at square and y is 280. This one times this 280 plus 2 into x is 80 square and y is 280 plus x square, which is a square t power of 4. This one times 2. So now if you simplify here, this becomes 4 to the 8, a cube and t cube, plus this 2 to the 4, a square t cube. So if you this one if you multiply 2 to 4 and 4 to 8, a cube t power of 4, plus this one 4 a square t cube into 2, 4 to the 8, that a power of 3 t power of cube, plus this one, this 2 a cube and t power of 4. So now if anything is common, you can 8 a cube and this one is same only. So this is correct, 16 a cube and t cube, and plus this one 8 plus 2 10 a cube and t power of 4. So this is the answer. Now we have to verify by the direct substitutions here. So you can substitute directly here, whatever the value is given here only you can substitute and differentiate. So z is equal to this x square y plus y square of x, this one. Yeah, whatever opposite given here, no problem. X y square plus this x square y, and x is equal to 80 and y is equal to 280. This one, and the question is given here. We'll substitute directly here in the place of x and y. So x is equal to 80 square and y square is equal to this one, I get it 4 a square t square, plus this one a square t power 4 and y is this 280. So if you multiply here, we'll get it this 4 a cube t power of 4 plus this one is 2 times of a cube and t power of 5. So now this one dz by dt, to find it here, this one we correct 4 a cube with the constant, t power 4 differentiation is 4 into t power of 3, plus 2 a cube is constant and t power 5 is 5 into t power of 4. So we'll get it here 16 a cube t cube plus 5 to the 10 a cube and t power of 4. So this and this one is same answer. So we are able to verify here by using the direct substitution. Question number 3, z is equal to given 2x y square minus 3x square y. If x increases at the rate of 2 centimeter per second, it passes through the x at 3 centimeter. So you can write here dx by dt is equal to 2 centimeter per second and x is equal to 3 centimeter. So if y passes through the value of y is equal to 1 centimeter, y must decrease at the rate of this dy by dt, that must decrease at rate of minus 2 by 15. So you can write this one is 13 plus 2 minus 32 by 15. This one we need to put there. Here also then z is dependent upon the x and y, and this xy is dependent upon the t. So same we can write this total derivative dz by dt is equal to del z by del x into dx by dt plus del z by del y into dz, this dy by dt. So this value is what 0 here because it's passing. If so that y passes through the value of 1 centimeter, that x is decreasing. So this part is 0. Del z by del x, if you differentiate here, we'll get it. This one 2y square minus 6xy plus into this dx by dt, which is given 2 plus del z by del y with respect to y. If you differentiate, we'll get it here 4xy minus 3x square into dy by dt we have to find it. So from this one we can write dy by dt is equal to like minus of 2 times 2y square minus 6xy divided by 4xy times minus 3x square. This one. Now you put the values here. X is equal to 3 centimeter, y is equal to 1. So dy by dt will get it here minus 2. This one is 2 into 1. So this is 2 minus this is 6 into 3, 18. This one 4 into 3, 12 minus this one is 3 square 9, 3 is 27. So we'll get it here minus 2 into minus 16 divided by minus 15. So this become plus here. This is 32 by 15 and minus indicating is decreasing here. So we got the same values here. Dy by dt. We need to show here this is dy by dt is decreasing with this one, and this minus indicates here dy by dt value is decreasing. So in this question given z is equal to f of xy and x is equal to e to the power of u cos of v and y is equal to e to the power of u sin of v, and we need to show that these two part. So let's consider for the first one. They are given y with respect to del z by del u. So you find here this del z by del u. So you can see here this z is actually depend upon the x and y, and this xy also depend upon the two variables u and v. So this is partial differentiation del z by del x. This is also partial differentiation del z by del y because we having the two variables. Now here x also having the two variables. So this is also in two variables here. So here also partial differentiation. So we can write like this: z is depend upon the x and y, and this x is depend upon another variable u and v, and y also in term of u and v. So this is partial del z by del x, del z by del y. This is also partial differentiation because it depend upon the two variables. So you can write del x by del u, and this one I can write del x by del v. This one del y by del u, and this is del y by del v. So first we want to find del z by del u. So del z by del u means z to u 1 2. So z to u we can go by this way, this and this one, or this and this. So these two formula you need to write here like that. I will tell you. See here. This we can write del z by del x times this dx by du, or means plus. We can go by this way. So this is del z by del y into this dy by del u. This one. I will substitute the values all here. So del z by del x, z is equal to given in term of functions. So write as it is only. This one del x by del u. This one if you differentiate with respect to u, so cos v is constant, e power u differentiation is e power u cos of v, plus del z by del y I will write as it is, and this y with respect to u. So same here, e power u as it is, and sin v as it is. E power u differentiation is e power u with respect to u. So this you got it here, del z by del u. Now if you want here we can write it, this is just like a same as a this del z by del u is equal to, this is just same as x only. So we can write in the place of this one is x. So x into del z by del x, plus this one is just y. So y times of del z by del y. So we can write here del z by del u is equal to this one here, and now in the coefficient in the questions we have to multiply y. So I will multiply this one y here. So I will get it here, this xy del z by del x plus y square del z by del y. This is the first part. First part means this one here, this part. Similarly, we can write for the del z by del v also. So v we need to go by this one and this one, and then this and this. So I will write it here. This del z by del v is equal to del z by del x into del x by del v plus this del z by del y times this del y by del v, this one. So del z by del x as it is, because z is the given in the functions here, so we cannot differentiate. If you write f dash of x, you can write it, but leave as it is. Now this del x by del v, this x with respect to v, so e power u and cos v becomes minus sin v. So this becomes e power u and cos v with differentiation with respect to v is minus sin of v plus del z by del y as it is, this y with respect to v. So y with respect to v, this sin v become cos v and e power u as it is. So e to the power of u cos of v, this one. So here this is just like a y only, so we can write this is minus y into del z by del x plus this is x only, this is x only. So we can write here x into del z by del y, and that is equal to del z by del v, and in del z by del v coefficient is x here. So x if you multiply, so this becomes yx and this is x square. So this is the equation 2. So this one 1 and 2, if you add it this left hand side, we will get it here y into del z by del y plus x into del z by this is v, this u. Okay, this is u. So you can write here y into del z by del u plus x into del z by del v is equal to this one, and this one will get cancelled here, this part. Okay, this part and this part will get cancelled here, we'll get it this one. So we can write here del z by del y is common, so we'll get it x square plus y square. So del z by del y and x square means e power of 2u and cos square of v. We can put the values of this x, and this e power of 2u sin square of v. So we can write here e power of 2u common here, this sin square of v plus cos square of v is equal to 1. So we can write here y into del z by del u plus x into del z by del v is equal to e to the power of 2u times del z by del y. So this was the first proof, this one. Now for the second case, we will start from the right hand side. So this del z by del u, that whole square, this which is given, this del z by del u, this one we will x value, this original value of x will put it this, like you can use this one here better. This is del z by del u, this one you make it a square, this we can write here this is a, and del z by del v, which is this equations b, del z by del v, this one you can make it a square. Okay, and then so if I write it that a part, I can write it here, this del z by del u is equal to that del z by del x into e to the power of u cos of v, this differentiation, plus del z by del y into e power of u sine of b. So this one, if you bring this e power u common here at this side, so you get it e to the power of minus u into del z by del u is equal to del z by del x into cos of b plus del z by del y into sine of b. So now we make it a square both sides. So we'll get it here, this e to the power of minus 2u, this one del z by del u whole square, and this one means full terms we have to write it as square. So this is just like a plus b whole square. So this is del z by del x whole square into cos square of b plus del z by del y whole square into sine square of b plus 2 into ab del z by del x into del z by del y into sine of b into cos of b. This one. Similarly, for b was this one. So this one, if you do e power of u out this side, so it becomes e to the power of minus u, and this I will write it here. This del z by del b is equal to that minus of that del z by del of x minus e to the power u sine of b, and plus del z by del y into differentiation was there, so e to the power of u cos of b. So this is e power of u outside here, so e power minus u del z by del b is equal to, we can write it here without this e power of minus u, so del z by del x minus sine of b plus del z by del y cos of b. So this one you can square here both sides. So this becomes e to the power of minus 2u del z by del b whole square. This is a and b total whole square, so a minus b whole square. So just like a square plus b square minus 2ab. So del z by del x whole square sine square of b plus del z by del y whole square cos square of b minus 2ab, which is del z by del x and del z by del y into sine of b into cos of b. So this consider this is c and this is d. So this c and d, if you add it here, so the left hand side will get it here, e power of minus 2u common, this del z by del u whole square plus del z by del b whole square, and right hand side this part will get cancelled. I'll write with a different color. This part and this part will get cancelled. So here we can take common here del z by del x. So sine square plus cos square v, sine square v plus cos square v 1. So we can write only del z by del x whole square plus this one, we can write this one and this part. We can take del z by del y square outside. The sine square v plus cos square v is 1. So we can write del z by del y, this one whole square. So this one was the answer here, and we need to prove this one. This one is equal to this del z by del x plus del z by del y whole square. We got it. So proof. So in this question, it's given u is equal to in term of r, s and t, where r in term of x and y, and s is y and z, and this t is in z and x. So we can say that here u is given in the function of r, s and t, and this we can write r in term of xy. So this x and y. If you want write z also, it will come 0. So no need to write it better. R is what in term of x and y, and s in y and z, and t is in term of this z and x. Okay. So now we need to find here first one, this del u by del x. So this del u by del x means we need to go from u to x here. So how many way you can go? This is the partial differentiation, so that's del u by del r. This is del u by del s. This is del u by del t. This is del r by del x. This is del r by del y. This is del s by del y. This is del s by del z. This is del t by del z. And this is del t by del x. So you want to go to u to x. So where is x here? In this one is there, and this one is there. So you can write here directly from this del u by del r times del r by del x, or this one del u by del t into del t by del x. If you want to write x, y, z, if you write it also, no problem. If you write for the here x, y, z also, so you should write here del u by del s into del s by del x. So anyways it will come 0 here, so if you write also it's fine. Otherwise this is the short form you can write. Depend upon the whatever the variable, directly you write it the values. No need to write all this in term of this r, s, t in x, y, z. So now if you substitute these values here, this del u by del x we can write it here del u by del r. Del u by del r means this function is given, so you write as it is only. Del r by del x, this one with respect to x. So 1 by y is a constant, and x differentiation is 1. So 1 by y plus del u by del t as it is, and this one del t by del x, t with respect to x. So z is a constant, and 1 by x differentiation is minus of x square. This one. In this we need to multiply here x. You can write here x into del u by del x is equal to del u by del r into x by y plus this one del u by del t. This one 1x will get cancelled here, you'll get it minus z by x. This is just let's consider this is a. A means this is the first part. Similarly we can write for the all y into del z del u by del y is equal to, we can write here, yeah, better I'll do a step by step here. This del u by del y formula you write it first. Del u by del y means we need to list from the y is here and here. So del u by del r and del r by del y plus del u by del s and del s by del y. So this one if you write here del u by del r as it is, this r with respect to y. So r is with respect to y here. So this x is constant here. 1 by y differentiation is minus 1 by y square plus del u by del s into del s by del y. Del s by del y becomes 1 by z. So in this one we need to multiply here y. So this is del u by del y. If y multiply, so I will write it here. So we'll get it here del u by del r. Y if you multiply, so 1 y will get cancelled here, we'll get minus x by y plus del u by del s times left y by z. That is b. We made this part. Now similarly you write for the del u by del z. Del u by del z formula, first write it here, z is where? This and this. So we go from del u by del s to del s by del z plus del u by del t into del t by del z. So del u by del s as it is, del s, this del s by del z, s with respect to z, so minus y by z square plus del u by del t as it is into del t by del z, del t by del z, t with respect to z is 1 by x. So if you this is del u by del z, if you multiply with this one with what, we need to multiply with the coefficient z. So z, if you multiply in this one z times del u by del z, so z if you multiply, so this one z will get cancelled, so we get del u by del s into minus y by z plus del u by del t times this one with respect to multiply with z, so z by x. So this is third C. So now if you add this left hand side, is equal to, we can write it here, this del u by del t and this z by x, this part is cancelled. I'll write with a different color so will not confuse. This and this is cancelled. This one cancelled, and this one cancelled. So we'll get it here. This is as this.